So for ionisation of water, we have effectively have something called KW. So KW is it's a concentration of H pluses and concentration of OH minuses. And no matter what the pH is, at certain temperatures, the product of these will be constant. So at standard temperature pressures, the KW is 1 times 10, or 1.00 times 10 to the minus 14. So the product of those two, when you times them together, you'll get this number. So that means if we know the OH minuses or we know the H pluses, because when they both times together, they get 10 to the minus 14, we can work out the other one. So it can be used for working out OHs. We're going to do that next week. The next thing what we can do is we can use this to work out the pH of water. So back when you were in year 7, 8, 9, you know that neutral is pH 7. That's not quite true. So if we were to set up H2O, an equilibrium making H pluses and OH minuses. At this point, we are breaking and making bonds. If we're breaking bonds, that is an endothermic process. So this is endothermic, and this is exo. And that means if we have our water and we heat it up, we are going to get more H pluses. If we have more H pluses, we know, if we have more H pluses, the concentration of H plus goes up, the concentration of our protons goes up. If we now know that minus log of our concentration is our pH, if this increases, the pH must change. So when we actually change the temperature of water, we increase the pH if we increase the temperature. So that means that our old definition of neutral being pH 7 is not correct. When we get a question for why is water neutral, it's actually really, really simple. The concentration of H pluses is equal to the concentration of OH minuses. That is what tells us that it is neutral. So if something has the same concentration of H pluses and OH minuses, it must be neutral. So if we have this figure, so this is at 298K, we can work out the pH of water using this. So let me just get rid of this. So if my KW, so at this temperature, say my KW is 1.00 times 10 to the minus 14, and that is equal to H plus and OH minus. Because this is water and these are equal, because it's neutral, we can just replace OH minus, because it's the same number, we can change that to an H plus, because it's the same concentration, and therefore we've got our KW is equal to H plus squared. So now if we square root 1.00 times 10 to the minus 14 is equal to H plus, we now have a more realistic number, or sorry, not more realistic number, we have a number that we can just work out, and we can do a minus log 10 of it. So if you do a minus log of this number, which is going to be 1.0 times 10 to the minus 7, you get 7. So the pH of water at 298K is 7. And if you wanted to work it out at any temperature, all you would need is the KW. So in your books, you've got a lovely table of all the KWs at different temperatures. So if we were going to go at 373 Kelvin, the value for KW, it's rubbish, it needs to be little w, the value for KW is 51.3 times 10 to the minus 14. So that's the value for KW at water at 373K. So all we'll do is put it in this, So 51.3 times 10 to the minus 14 is equal to, so it's h plus the product of these two, but because it's water and they're the same, we have 51.3 times 10 to the minus 14 is equal to h plus squared. So if we square root it, so 51.3 times 10 to the minus 14, that gives us the concentration of H plus. So then if we were to do minus log of that number, 51.3 times 10 to the minus 14 square rooted, that would give us the pH of water at that temperature. And even though it's not pH 7, it's still neutral because concentration of H plus is equal to concentration of OH minuses. So this method is the same every single time. You get given the kW of water at a certain temperature, and you would need to work out the pH. Or if you get given the pH, you would then do 10 to the minus of the pH. You'd work out your concentration of H pluses. Then you would simply do this divided the concentration of H pluses, gives you the concentration of this. Well, there's lots of things you can do to work out different values, because this is all that they can ask for kW. It is relatively simple, as long as you understand it. The only questions that we have to do on this are the summary questions on page 317, and the summary questions, a couple of them on page 321. So if you have a go at those, that's all we need to do for today's lesson. So have a try of those. I'm going to be hanging around here until the bell goes. So obviously you can ask me questions, but have a go at those and then we'll be done.